Come with me on a journey beyond the rocky inner worlds, past the asteroid belt, into the realm of the gas giants. Here reigns Jupiter, the king of planets, named after the supreme Roman god. Jupiter is so immense that all the other planets could fit inside it, with room to spare. This swirling giant orbits the Sun at a staggering distance, over 778 million kilometers away. Sunlight here is faint and cold, and the journey from Earth takes years, a testament to our solar system's vastness. On a clear night, Jupiter shines as the fourth brightest object in our sky, a steady beacon that has captivated humanity for millennia. Its diameter is over 11 times that of Earth. If Earth were a grape, Jupiter would be a basketball. Its mass is more than twice that of all the other planets combined, giving it a gravitational pull that shapes the fate of comets and asteroids. Jupiter's powerful gravity has played a crucial role in the story of life on Earth, acting as both protector and influencer. It is a heavyweight champion of worlds, a cornerstone of our solar system's architecture. This is Jupiter, our cosmic guardian, swirling in the dark, watching over us since the dawn of our species. Let's explore what makes this giant so extraordinary. Through a telescope, Jupiter reveals a masterpiece of swirling clouds. No solid surface, just vibrant bands of orange, white, red, and brown. These bands, called zones and belts, are fast-moving jet streams of gas, flowing in opposite directions at hundreds of kilometers per hour. The lighter zones are regions of rising gas and ammonia ice, while the darker belts are sinking gas, revealing deeper reddish-brown clouds. The exact chemistry behind these colors remains a mystery, but compounds of sulfur and phosphorus reacting with sunlight play a role. Jupiter's most iconic feature is the Great Red Spot, a colossal storm, larger than Earth, raging for centuries. This anticyclone spins in the southern hemisphere, a hurricane of unimaginable proportions. The Great Red Spot has shrunk in recent decades, but remains a powerful testament to Jupiter's violent weather. Jupiter's atmosphere is a chaotic canvas, filled with countless storms, some white, some brown, appearing and vanishing across its face. In the southern hemisphere, a string of white ovals known as the String of Pearls can last for years. All these storms are driven by heat rising from Jupiter's deep interior, turning the atmosphere into a turbulent spectacle. Jupiter is a world in constant violent motion, where the weather is always extreme. It's a planet of perpetual storms and breathtaking beauty. Beneath Jupiter's cloud tops lies an atmosphere of staggering depth and pressure. No solid surface, just denser, hotter gases as you descend. The outer layers are mostly hydrogen and helium, like the Sun, but deeper down, pressure transforms hydrogen into a liquid, then into a metallic state. Imagine falling into Jupiter. Pressure increases 1,000,000 times greater than Earth's, and you'd swim in an ocean of liquid hydrogen. Deeper still, hydrogen becomes metallic, creating a vast, spinning ocean that generates Jupiter's immense magnetic field. This magnetic field is nearly 20,000 times stronger than Earth's, creating a huge magnetosphere that traps charged particles and produces intense radiation belts. Jupiter's magnetic field also creates spectacular aurorae, northern and southern lights far larger and more powerful than Earth's, glowing in ultraviolet and X-ray. These aurorae are a shimmering crown, a sign of the immense energy within Jupiter's metallic heart. The entire planet acts as a colossal electrical generator, a powerhouse of the solar system. Its environment is hazardous for spacecraft, but it's a scientific treasure trove. Jupiter's atmosphere is a realm where the very definition of air changes, and the forces at play are beyond anything on Earth. It's a world of extremes, both beautiful and dangerous. Jupiter is orbited by a fascinating family of moons, forming a miniature solar system of its own. In 1610, Galileo discovered 4 bright moons, Io, Europa, Ganymede, and Callisto, revolutionizing our view of the cosmos. Io, the innermost, is the most volcanically active body in the solar system, its surface constantly reshaped by eruptions. This volcanic fury is caused by a gravitational tug-of-war with Jupiter and the other moons, heating Io's interior. Next is Europa, a world with a bright icy shell and a vast subsurface ocean, one of the most promising places to search for extraterrestrial life. Europa's ocean, warmed by tidal forces, could harbor life in its dark depths. Ganymede, the largest moon in the solar system, is bigger than Mercury and has its own magnetic field, generated by a liquid iron core. Its surface is a mix of ancient, cratered terrain and younger, grooved regions. Callisto, furthest out, is a heavily cratered ancient world, a frozen record of the solar system's violent history. Each Galilean moon is a unique world, offering clues to the processes that shape planets and moons. They are more than satellites. They are destinations for future exploration. Jupiter's moons are as captivating as the planet itself. They beckon us to explore their mysteries. Beyond the Galilean moons, Jupiter shepherds a vast flock of nearly 100 smaller moons. Most are irregular, likely captured asteroids or comets. These moons travel in diverse orbits, some even moving in the opposite direction of Jupiter's rotation, hinting at a chaotic history of capture. Studying these moons helps us piece together the solar system's dynamic past, filled with collisions and gravitational dances. Jupiter also has rings, faint, dark, and difficult to see, discovered by Voyager 1 in 1979. Unlike Saturn's icy rings, Jupiter's are made of tiny dust particles, likely kicked up from its innermost moons by micrometeoroid impacts. The ring system consists of a main ring, a cloud-like halo, and two faint gossamer rings stretching far out. These rings are dynamic and transient, constantly replenished as dust is pulled in or blasted away by Jupiter's gravity and magnetic field. They are a subtle, ghostly halo, a reminder that even on a planetary scale, nothing is permanent. Jupiter's rings and moons reveal a system in constant motion, always changing. The planet's gravitational influence shapes not just its own system, but the entire solar neighborhood. Jupiter is a cosmic shepherd, guiding and shaping its family of moons and rings. Its story is one of creation, destruction, and endless change. Our knowledge of Jupiter comes from daring robotic explorers. Pioneer 10 and 11 were the first to visit in the 1970s, braving intense radiation and sending back our first close-up images. Voyager 1 and 2 followed, transforming Jupiter from a distant point of light into a complex, dynamic world, revealing its rings and Io's volcanoes. In 1995, Galileo became the first orbiter, dropping a probe into Jupiter's atmosphere and studying the planet and its moons for 8 years. Galileo provided strong evidence for Europa's subsurface ocean and discovered Ganymede's magnetic field. Today, the Juno mission orbits Jupiter, mapping its magnetic and gravity fields, studying its aurorae, and probing its deep interior. Juno's close passes reveal a planet more complex and beautiful than we imagined. Each mission has rewritten our textbooks, unveiling new mysteries and deepening our curiosity. Robotic explorers have shown us Jupiter's storms, moons, and rings in stunning detail. Yet every answer brings new questions, fueling the next generation of exploration. Jupiter remains a frontier, waiting to reveal its secrets. Jupiter is a planet of extremes. Despite its size, it spins faster than any other planet, completing a rotation in under 10 hours. This rapid spin creates powerful jet streams and storms, and causes the planet to bulge at the equator. A day on Jupiter is a dizzying blur, but a year lasts nearly 12 Earth years. Its slow orbit tugs on other planets, shaping their paths over millions of years. Jupiter's storms are powered by internal heat, not sunlight. It radiates more energy than it receives, fueling storms that can last centuries. The Great Red Spot is just one example of these colossal, long-lived tempests. Jupiter is sometimes called a failed star. It's made of hydrogen and helium, but never grew massive enough to ignite nuclear fusion. If it were 80 times more massive, our solar system would have 2 suns, and life on Earth might not exist. Jupiter's failure is our fortune. Its presence has shaped the solar system and made life possible. It is a king of planets, but never a king of suns. Jupiter's extremes make it endlessly fascinating. Jupiter's gravity is a cosmic shield, protecting the inner planets from countless comets and asteroids. It deflects or destroys many potential impactors, reducing the threat to Earth, a role written in the craters of the Moon and planets. Without Jupiter, Earth would face far more frequent catastrophic impacts. The comet Shoemaker-Levy 9's collision in 1994 was a dramatic example of Jupiter's protective power. But Jupiter's influence is complex. Its gravity also created the asteroid belt, and sometimes sends asteroids toward the inner solar system. Jupiter both protects and perturbs, shaping the architecture of our planetary neighborhood. Its migration in the early solar system may have scattered material, influencing the formation of Earth and delivering water and other ingredients for life. Jupiter is our guardian, shaper, and cosmic big brother. Its presence has made Earth a safer, more habitable world. The story of life on Earth is intertwined with the story of Jupiter. Our exploration of Jupiter is just beginning. Missions like Galileo and Juno have deepened our curiosity, raising new questions about Jupiter and its moons. NASA's Europa Clipper and ESA's JUICE missions will soon explore Europa and Ganymede, searching for signs of life and unraveling their mysteries. Human missions to Jupiter's moons remain science fiction for now, but the dream persists. The challenges are immense: distance, radiation, and icy surfaces, but the lure of discovery is powerful. One day, our descendants may stand on a Jovian moon, gazing at Jupiter's swirling clouds. The journey to Jupiter has taught us about planetary systems and our place in the cosmos. The next chapter promises even greater discoveries, continuing humanity's grand adventure into the universe.